what is the fourth dimension? Everyone knows 1D, 2D, and 3D. But what about 4D? What is the fourth dimension? What would it look like? It's hard to picture a fourth dimension because we only live in 3, but let's try it out. The easiest way to picture a 4D world is to imagine what a 3D one would look like from a 2D perspective. To help us with that, meet my friends, Jane and Tom. They live in a 2D world inside our 3D one, but Tom and Jane can only see and interact with things inside their own 2D plane of existence. In the same way, if we lived within a 4D plane, we would only be able to see and interact with the things inside our 3D plane. But what if a 3D object entered Tom and Jane's world, or a 4D one entered ours? Tom and Jane would only be able to see the 2D cross-sections of the object that currently occupied their plane. So say a strawberry passed through their 2D world. Tom and Jane would just be able to see strawberry-shaped cross-sections of that fruit until it was out of their plane altogether. In the same way, if a 4D cube or hypercube passed through our 3D plane, we'd only be able to see 3D cube cross-sections of the 4D hypercube. Now say we decide to pick up Jane and take her out into the 3D world. What would she see? What kinds of stories would she have to tell Tom when she returned? Even though Jane would be out in our world, she wouldn't be able to see all the things that we can see. Her 2D eyes would only be able to make out 2D cross-sections. If we take Jane past a ball, it would first enter her field of vision as a point, and grow into a circle the size of the diameter of the ball, then shrink away to nothing. If we encountered a hypersphere, a very similar thing would occur. A small ball would appear, then grow into a large sphere, and then shrink away to nothing. Alright, Jane has had her fun. Let's take her back home and see Tom. Wait a second, something seems off. Jane doesn't look quite how she did before. Oh, I see what happened. We accidentally set Jane down, flipped over. Jane is only 2D, so she doesn't have a back like we do. So when we flip her in 3D, she becomes the mirror image of herself. That's something important to remember. Handedness isn't fixed when we interact with higher dimensions. Jane was right-handed before the flip, but now she's left-handed. And her dress got flipped around too. We don't have a backside in the 4D sense either, so if we were flipped around in the fourth dimension, we would become mirror images of ourselves. Pretty cool, right? Okay, so you've probably heard of curved space, but do you know what that means? Tom and Jane can help show you that too. See, we can curve Tom and Jane's world pretty easily, and to us it looks like their flat world has become a cylinder. But they can't tell anything has happened. That's because the geometry of their plane has remained the same, so to them it's still flat. The plane is curved, but in the third dimension, that they can't see. The only way Tom and Jane would be able to detect this curvature is if they traveled all the way around their plane, because they would end up back where they started from. It's possible that our 3D universe is curved like this, although we don't know for sure. Scientists are looking up at the stars to see if they can detect any repeating patterns indicating light traveling all the way around the universe multiple times, thus putting its mark in the sky multiple times. Higher dimensions are cool to think about and help us understand some of the crazy ideas you may hear scientists discussing. The biggest application of higher dimensions is string theory, which claims there are 11 different dimensions in the universe, but most of them are rolled up even smaller than Tom and Jane's dimension. String theory is an attempt at unifying all the fundamental forces in physics, and who knows, maybe someday you could be the one to prove it.